Hello everyone, myself P.Jithendar, Assistant Professor in Electrical and Electronics Engineering, MLR Institute of Technology. So in today's video session, I am going to discuss about the problems on transient analysis of series RL circuit with differential equation. So here, we need to discuss about the problems on the transient analysis of series RL circuit. So here I am taking the one problem here. So we are having the source voltage is 60 volt. So 60 volt is positive and negative. So we are having the source voltage is 60 volt and resistor R is 30 ohm and inductor L is 15 Henry. So here by using this given series RL circuit, we have to find out the current response of the series RL circuit. So in this circuit, we have to calculate I of t. So we need to calculate the current response, that is I. Okay. And so for this, what we need to do? So first, we need to apply, or we need to write the voltage equation of the resistor and voltage equation of the inductor. So here the voltage equation of the resistor is, so across the resistor R. So already we know the equation. So VR is equal to I into R is the voltage equation of the resistor, and the voltage equation of the inductor is VL equal to L into DI divided by DT is the voltage equation of the inductor, right? So here, VR is equal to I into R, where I is constant here, but we are having the different voltage drops at resistor R, that is VR, at inductor L, that is VL, right? So VR is equal to, so R is nothing but 30 ohms. So R value is 30 ohms here. So 30 into I. So VR value. So VR is equal to 30 into I, and VL is equal to, so L is nothing but 15 Henry. So right. So inductor L is equal to 15 Henry, that is 15 into di divided by dt. So now we are having VR voltage equation, voltage across the resistor and voltage across the inductor L. So VR is equal to 30 into I and VL is equal to 15 into di divided by dt. So now here we need to apply KVL in a given single loop. Now we need to apply the KVL in a given single loop, right? So here, so we need to apply KVL. So here, so apply KVL in this equation. So here in this case, I am starting from this point. So when I am starting from this point, and this is the starting point, and also this is the ending point. So we are applying the KVL in this loop. So here I am starting from this point. So here plus 60 minus VR minus VL equal to 0. So 60 minus VR minus VL equal to 0. Or also we can write 60 equal to VR plus VL. So 60 equal to VR plus VL, where so we are having VR and VL here. Now we need to substitute VR value and VL value in this equation. So now we will get 60 equal to, so VR is 30 into I plus VL is 15 into DI divided by DT. Now this equation I am writing like this. So 15 into DI divided by DT plus 30 into I equal to 60, right? Now in this equation, take 15 as a common term here. So here 15 into di divided by dt plus 2 into I, that is equal to 60. So now, so di by dt plus 2i equal to, so 60 divided by 15. So here the equation is di divided by dt plus 2i equal to 4. Right, here is the first order differential equation. So now this equation is looks like di by dt plus pi, that is equal to q. Right, now for this equation, so we need the total current equation of for this differential equation is I equal to IC plus IP. So IC is the complementary function, IP is the particular integral, right? So now we have to find out IC value and IP value. So before that, so compare these two equations. So in these two equations, where P equal to 2 and Q equal to 4. Now find out, so let us take as this is equation number 1. Now find out IC, where IC equal to C into e to the power of minus integral of P dt is the equation. So that is equal to C into e power minus integral of P. So P already we know, so P equal to 2. So 2 into dt, that is equal to C into e to the power of minus integral of 1 into dt is t, that is IC value. So complementary function IC equal to C into e to the power of minus 2t. So complementary function. Now particular integral, that is IP. So we need to find out the IP here, where IP equal to e to the power of minus integral of p dt into integral of q into e power p dt into dt is the equation. So that is equal to e to the power of minus p value. So what is p value here? P value is 2. So 2 into dt into integral of q. So what is q here? 4. So 4 into e power integral of 2 into dt into dt. So now here we have to simplify the equation. So that is equal to e power minus, so 2 is constant. So 2 into integral of 1 into dt is t, e power minus 2t into, so 4 is constant. So 4 into integral of e to the power of integral of 2 into dt. So e power 2t into dt. Now that is equal to e power minus 2t into 4 into, so integral of e to the power of 2t dt is e power 2t divided by 2. Now e to the power of 2t and e to the power of minus 2t get cancelled, that is equal to, so 4 by 2 is 2. So here IP value is equal to 2. Now we need to substitute IC value and IP value in the total current expression, that is I equal to IC plus IP, where IC equal to, so IC equal to C into e to the power of minus 2t. So C into e to the power of minus 2t plus IP value is 2. Here is the current response. So in this equation we are having the constant term, that is C here. Now we need to calculate the C value. Okay. So now we need to find out C here, that is constant C. So here already we know, initially for this transient analysis, initially if t equal to 0, then I also 0. Now substitute this t value and I value in this equation. So I is 0, that is equal to c into e to the power of minus 2 into t, 0 plus 2. So 0 equal to, so e power minus 2 into 0 means e power 0. So e power 0 is 1. So c plus 2, where c equal to minus 2. Now substitute this c value in this equation. Now we'll get the total current response I equal to c into e power minus 2t plus 2. Now c equal to minus 2 into e power minus 2t plus 2. That is I. So where I equal to, this equation I am writing like this. So here 2 minus 2 into e power minus 2t. Now in this equation 2 is the common term here. Then the total current response of given series RL circuit is 2 into 1 minus e to the power of minus 2t is the total current response of the given series RL circuit. So this is the total current. Now similarly, we need to calculate the voltage drop across the resistor and voltage drop across the inductor. So here we are having the total current I equal to 2 into 1 minus e to the power of minus 2t. So this is the total current response of the given RL circuit. So now we need to calculate voltage drop across the resistor, that is VR is equal to I into R, where I is 2 into 1 minus e to the power of minus 2t into R value. So R is nothing but resistance value, that is 30 ohm. So into 30, that is equal to 60 into 1 minus e to the power of minus 2t is the voltage drop across the resistor R. Now similarly, we need to calculate voltage drop across the inductor, that is VL. So VL is equal to L into di divided by dt, that is equal to, so L value is 15. So L is 15 into d by dt of current value. So 2 into 1 minus e power minus 2t, that is equal to, so 2 is constant. So 15 into 2 into d by dt of 1 minus e power minus 2t, that is equal to 30 into, so now d by dt of 1 is 0 minus d by dt of e to the power of minus 2t is e power minus 2t into again d by dt of minus 2t is minus 2, that is equal to, so minus into minus plus, so 30 into 2, 60 into e power minus 2t is the voltage drop across the inductor L. Here is the total current equation and voltage drop across the resistor and voltage drop across the inductor. Here is the calculation problems on the transient analysis of series RL circuit. So thank you one and all.